Welcome to Khetztutorials, and this is the first video under analytical geometry, and I'm basically going to extend this towards circles or circle geometry or analytical geometry, which is linked to the equation of a circle and how you deal with circles. So I just thought it would be best to just summarize the important formulas which we are going to use in the upcoming videos. So let's start. So the first formula that I want to talk about is the gradient formula, and this just basically pops up everywhere, functions and basically everywhere. I just can't think of other places right now, but basically it appears everywhere. And it can be said to be the average gradient, as I briefly explained in the calculus section. So you can write this as average gradient, AVG for average gradient. And it's basically the gradient between 2 points. Let's say you have A and you have B, and you have a line which joins these 2 points. Now, if you want to find the gradient between these 2 points, let's say they are defined by these coordinates, then this is a Y, by the way. Looks funny, but it is a Y nevertheless. Now, if you want to find the gradient, which is denoted by M, of a straight line which joins 2 points, you basically use this formula which says change in Y divided by change in X. And these changes are basically related to you subtracting one Y from the other. So it doesn't matter which one you start with, just make sure that you have the same one starting at the top and at the bottom. So you can find the gradient even if you maybe started with this one. But just make sure, once again, that the numbers or the coordinates actually match in pairs. So just make sure of that. So you can start with any, you can start with B, you can start with A, doesn't really matter, as long as you keep the order of your Y's and X's. So that is how you'd find the average gradient. And once again, I'm just going to talk about formulas in this video and not necessarily about any examples, but we'll see. So let's move on to the next formula that I want to talk about, and that would be the distance formula. The distance formula. Now let's say we have, once again, A and B. And we want to travel either from A to B or from B to A. And the task at hand is basically to find the distance. So let's say you wanted to measure the distance between these 2 points. We have a tape measure, and you basically extend it to there. Someone's holding it maybe on this side. And we are now asked for the length or the distance between these 2 points in units. Units can be anything, centimeters, meters, just about anything. If it's not specified, then you usually just write units, right? Just to be safe, because most, if not all, mathematical quantities have units. And so the distance formula basically helps in calculating the distance between 2 points. And you can do that by saying, let me denote the coordinates as XA and YA, then XB and YB. So that the distance formula, or the distance between A and B, or the length of, here's another term for it, it's the length as well. So if you're ever asked to find the length, you use the same formula. So AB will be equals to the square root of YB subtract YA squared plus XB subtract XA squared. And once again, this is equivalent to starting with just about any order, as long as it's the same. And here specifically, you can see that because you have a squared over there. So if YA subtract YB is negative, once you square it, there's no difference from YB subtract YA. They'll come up as the same thing. If your answer was maybe -3 and you had to square it, it would be 9. If your answer for YB subtract YA was this, then it would be 9. You'd never know what actually happened, as long as you keep your order intact. So whatever starts here should start there as well. So that is another rule. And now when solving for stuff, it might be useful for you to square both sides. And if you square both sides of this equation, and this is what basically happens, And in most cases, this is actually useful. And that is how you go about solving stuff, or this is how you go about dismantling or putting this formula apart so that you can actually find something in here or there or whatever the case may be. Once again, we're only talking about formulas, so let's move on. So the next formula that I want to talk about is the midpoint. So the midpoint, and as the name suggests, we are talking about the midpoint formula. As the name suggests, we are talking about the middle or a middle section. So let's say we are here at A, and the end over there at the end we have B, and we want to find some middle point. Let's just assume that the middle point is somewhere there, somewhere in between, like literally in between A and B. So that means that the distance or the length from here to there is the same as the length from there to there. That is what the midpoint basically says. This is the middle, or it's the center, and we expect the distance in either direction to be equal or the same. So how do you find this middle section, or how do you find the midpoint? The way that you do that is basically if you have the coordinates of A, just like we did in the previous part of this, you basically have these coordinates just like that. This should be A. Right, so it's YA, XA, XA, YA. So let's say these are the coordinates that we have, and we now have to find this middle part, or the coordinates of this middle section. The way that you do that, you basically add your x's or your x coordinates of each of the points. Whatever the points are, doesn't necessarily have to be A and B. Whatever points that you have, if you want to find the midpoint, then this is basically what you do. And an example of this, one example that I can think of, or one use of the midpoint, is if you're told that the distance from here to there is basically, maybe if you have something like that and they specifically show that these two things are equal, then you can find the coordinates of that point if you have the coordinates of each of the sides. Or another application is if you have a circle. Let's say you have a circle and you have a diameter, and a diameter basically passes through the center. If you have this point and that point, you can find the midpoint, and the midpoint should be your center, because the midpoint of a diameter is basically the center of the circle. So let's say the question asks for the center of the circle, and you have points on either side of your diameter. So you have to make sure, first of all, that this is a diameter for it to give you the center correctly. Otherwise, it'd just be a chord which would not necessarily align with the center. So that is something to keep in mind as we go deeper into circles and analytical geometry, how you'd actually apply these formulas, or how you'd actually use these formulas. So let's move on to another formula, or let's talk about another concept. And the next concept that I want to talk about is the angle of inclination. So let's say you have a line like this, and when we talk about inclination, we are talking about the lift from a reference point. So a common reference point, or a universal reference point, is the positive x side, which is basically this side, which you can draw from just about anywhere. You can also have it somewhere there and pretend that it's basically moved up in a way. So this angle, this theta, that is how you pronounce this Greek symbol thingy, it's theta. Now this is your inclination, and it's actually related to this line by the gradient, or you can actually have, or you do actually have, a relationship between this angle and the gradient, and this is the relationship. So the gradient of the line is equal to the tan of the inclination of the line. So we said that the inclination is with respect to the positive x side, or this kind of line of reference that you have to the line. And if you have this angle, if you have that value, you can basically find the gradient of your line. And you can mix this around. If you have the gradient, you can find the angle, and so on and so forth. And the same thing applies if perhaps you have this line in the opposite direction or in another direction. Let me find another color and actually have this line maybe somewhere there or anywhere else. You can imagine your reference point and then go about having an angle. So these letters that actually represent the angle are not fixed. You can use just about any value of variable to show that it's indeed an angle. Once again, you can draw another reference point to actually find this, and anywhere on the line basically you can have your reference point, and that would define, or that would relate the gradient of your line to its inclination. So this is the inclination, just like in physics, just like in mechanics, stuff like that, your inclination. And let's move on once again to another formula. The next formula is the equation of a circle, which forms the bulk of what I will talk about in the coming videos. So now the equation of a circle, let's say we have, let me try to draw a proper circle. Let me pull up something here. I'm going to try to draw a proper circle. So let me pull this in there and then enlarge this circle just so we have some context. So, okay, let's assume that we are at the center, maybe something there. It's not exactly the center, but let's assume that this is the center. Now, the equation of a circle takes on the general form of x minus a squared plus y minus b squared equals to r squared. And I'm now going to basically define each of the variables. So x and y is just your basic x's and y's, which we have had all the time. But these ones are specifically on the circumference of your circle. So the x's and the y's that you actually find, or the valid ones which are part of the circle, are actually found on the circumference of the circle. So you define maybe a point somewhere there as x1, y1. It is on the circle, right? And let's move on to A and B. Now A and B are the coordinates of your center. So this is the standard form. Let's say you perhaps had x plus a squared, and you had coordinates for your center. Let's say your coordinates were 3, 5. And the question asks for the value of a. Your a in this case would be -3. And here's why. This is your standard form, and you always look at your equations and values in terms of the standard form. Now, if the given equation has a positive over there, you have to force your values to go towards the standard form. Now, to go back to the standard form, then you'd have to have something like this, basically. And the only way that you can have this from a positive is if your a is -3. So that is just a tip, or that is just an example of where you'd actually try to manipulate the stuff so that it's part of the standard form. So let's say, for example, you had coordinates and you're asked to find the a and b in this. So let's say this is the standard form. This is indeed the standard form. And now let's say you had coordinates 1, 6, for example. Now you just basically substitute them exactly as they are. The x value would go to the a and the y value would go to the b exactly as it is. And now this r over here is the length of your radius. Length of radius. And now your radius is basically any line, literally any line that moves from the center to the circumference. Any line, just about any line, doesn't matter where it is, any line which moves from the center to the circumference being any point on the outer line of the circle or the outline of the circle. So any line, doesn't matter where it is, that is not a radius. So I was trying to do this. So any line, doesn't matter which direction that it goes, doesn't matter where it is, as long as it originates from the center and it goes to the circumference, it is a radius. So if you have a point on your circumference and you know the coordinates of your center, you can find your r. Any of these ones can give you the r. Once you have the r, you can basically substitute it in there and you have your full description of your circle. So for example, let's say you had a circle with 1, 6 as your center, and you had another point over there, and your r, after finding this length, using the distance formula or using whatever information, you can be given that the diameter of the circle is maybe 10. So the diameter is twice the radius. So you'd know that your radius is the diameter divided by 2. So the diameter is a line which passes from one side of the circumference through the center and to the other side of the circumference of a circle. So it passes through the center just like a radius, but it's on both sides of your center. Now, it's basically twice the radius because the radius is from the center to the circumference. So you have lines from the center to the circumference twice, making a diameter. So you can find r in many ways, either using the distance formula, using the half of your diameter, or any other way which is given to you. So let's say your radius is now 5 and you have your center as 1/6. Then you basically just substitute into the standard form and you substitute that 5 over there, and you can further simplify your r on the outside as 25. This is valid, or this is perfectly fine. And that is how you deal with the equation of the circle, and we'll talk more about this later in another video. Now, moving on to another formula, we did talk about the straight line, so let's revisit that again. We started by talking about the gradient of a straight line, and the general form of a straight line looks something like this, or you can expand this to substitute a point on the line, and your formula can be something like this. And in both cases, your m would be the gradient. And I just showed you two ways that you can find the gradient. You can use the inclination, or you can use the average gradient formula using 2 points that are on the line. So the requirement for finding the gradient using the average gradient formula is that the 2 points that you use have to be on the line. So you can use just about any point as long as the point is on the line. And what else do I have to say about straight lines? Let's draw the Cartesian plane. And let's talk about vertical and horizontal lines before I talk about the last thing that I have to say. So a vertical line basically goes like, a vertical line goes like this. It's basically vertical, right? Straight from top down. So vertical is top down. Just keep that in mind. Vertical, top down. And horizontal, it's basically left to right. So left to right. So horizontal and vertical. So this would be horizontal, something like that. It will be horizontal basically. So now it's important to be able to differentiate between the two, because you might have a situation, let's say this is the Cartesian plane, and you have the x-axis and you have the y-axis over there, and you have a point 3 over there, and let's say you have 1 or 5 or whatever, let's say 10, whatever the case may be. Now, if I ask you, let's say I have an asymptote over there, or let's say I just have a line. Let's talk about lines for now, because we passed functions and stuff like that that has asymptotes. Let's say this line passes exactly through the 3, and it's a vertical line. What is the equation of this line? Just off of your head, you should know this. And the answer is that the equation of this line, it passes through the x, and what you have to note is that any point on this line has the same x value, because this line passes through 3 exactly. Even if you're here, it has 3. Let's say a point there has 3 with some y value which we don't know. And over there we have 3 with some y value that we don't know. You can't have another x value along this line. So how can we clearly define everything, or how can we clearly define that red line? And the answer is x equals 3. That is your definition of that red line, because everything along the line basically has that x value. And the same applies in the other direction, which would be your horizontal direction. If your line passes through any y value, I just used 3 as an example, just as I'm using 10 as an example. Now it passes through this y value, and you can say the same, but now in the y direction. This line is y equals to 10. Right? And this is particularly useful because you might be asked to find the distance between this point and that point. So in the distance formula, you don't have to compute your y's because they'll just cancel out. They're basically the same. They're both 10. The y values are both 10. You don't have to compute that. You just have to worry about the x's, and that actually saves you time. So it actually helps that you know that if you have a vertical line, this is a vertical line. If you have a vertical line, you can define it as x being equals to something, x1, if that is x1. And if you have a horizontal line, you can define it as y equals to that y1. And that is exactly what we did with these two lines, basically. So that is vertical and horizontal lines. That is what I wanted to talk about. And the last thing that I'll mention is the relationship between lines. So if you have parallel lines, I did talk about this in my previous video, but let me say it again. If you have parallel lines, they basically don't touch, and the relationship between them, so let's call this line y1 and call this line y2. So y1, let me just clear this up. y1 is parallel to y2 if and only if your gradient for y1 is equal to the gradient of y2. So they'll basically go in the same direction, but they never touch because they have the same gradient. So they're basically taking on the same slope, or they're basically going in the same direction. They'll never cross because they have the same grade. They will never cross. They have the same gradient. So this will just continue indefinitely. This will continue indefinitely, and they will never touch. So this is for parallel lines. They have the same gradient. So two lines which are parallel have the same gradients. So if they ever ask you what happens when this and that are parallel, or imagine that you have a line which is parallel to that which passes through something, you already know that the gradient of that line is basically equal to an existing line, or whatever line that you're being told to talk about or in reference to, right? And the last thing that I'll talk about is if you have perpendicular lines. So let's talk about perpendicular lines, like the Cartesian plane. The Cartesian plane itself has your x-axis in parallel, it's basically perpendicular to your y-axis. So being perpendicular basically means that they are 90 degrees away from each other, or with reference to one another. And that means that if we have lines which are perpendicular, it doesn't necessarily have to be the Cartesian plane. Let's say this is y1. Let's call this y1, and this is y2, the yellow one's line. So this is how you basically show it. So y1 is perpendicular to y2 if and only if the gradient of y1 multiplied by the gradient of y2 gives you -1. So if a question comes and it basically asks you to prove or to check whether two lines are perpendicular, this is how you do it. You basically multiply the gradients. If it gives you -1, then they're perpendicular. If you're asked to prove whether lines are parallel, you basically check if their gradients are equal, and if they are, you basically have parallel lines. So I believe I covered most, if not all, of the important formulas, which I will further expand in my discussion of analytical geometry in the coming videos. I hope you found something of value, that is, in this video. If you have any questions, absolutely any questions, just leave a comment. If you have anything to say, leave a comment, email me, whatever the case may be. If you want to book a session with me, just email me as well, and to let me know that you want my services or whatever the case may be. Finally, if you haven't subscribed, please subscribe. If you like the video, give it a thumbs up. I will see you in the next video.